This is problem 6 from chapter 13. The 10-pound block has a speed of 4 feet per second when the force of 8t squared is applied. Determine the velocity of the block when t is equal to 2 seconds. The coefficient of kinetic friction at the surface is 0.2. So first we have to determine what forces we have acting on the block. So we have this force of 8t squared. We have a force of kinetic friction, which opposes the motion. And we have a normal force, which is acting upward on the object, and the force of gravity, which is acting downward on the object. And that force of gravity is the weight of the object, which is 10 pounds. And we also have an initial velocity of 4 feet per second. So, after drawing our free body diagram, we apply Newton's second law in the y direction and also in the x direction. Let's start off looking in the y direction. In the y direction, the acceleration is 0, so the normal force is, in this case, just equal to the weight, because those are the only two forces that I have pointing in the y direction. And I want to use that to find the force of kinetic friction, and I take the coefficient of kinetic friction and multiply it by the normal force, and I get 2 pounds for the force of kinetic friction. Then I can come back and look at the sum of the forces in the x direction. This is equal to the mass times the acceleration in the x direction. I have a force of 8t squared pointing in the positive x direction, and a force of 2 pounds, which is the force of kinetic friction, pointing in the negative x direction. The mass of the object is equal to its weight divided by g, so that's 10 divided by 32.2. So now I have an equation for the acceleration. Well, I might want to bring the 10 divided by 32.2 over to the other side and say the acceleration in the x direction is 32.2 divided by 10 times 8t squared minus 2. Well, we have the acceleration as a function of time, but we want to know what the velocity is. But I know the acceleration is the derivative of the velocity with respect to time, or dv is equal to a dt, and I can integrate. Fortunately, I know what the initial velocity is, so I can put that in for the lower limit of integration, and then let's just use v and t for our upper limits of integration, and we can take this and put it in for the acceleration. When I integrate the left-hand side, I just get v minus 4, and then I have the integral from 0 to t of 32.2, which I suppose you could put outside the integral. And then I have a t squared minus 2 dt. Let's just call it 3.22 and bring that outside. And then when I integrate 8t squared with respect to t, I have 8/3 t cubed. Integrating negative 2 with respect to t gives me negative 2t. And then I put in my limits of integration from 0 to t, and I get v minus 4 is equal to 3.22 times 8 divided by 3, t cubed minus 2t. Okay, so then I'm looking for the velocity when time is equal to 2 seconds. So v, when t is equal to 2 seconds, is equal to, we can bring the 4 over to the other side, so I have 4 plus 3.22 times 8 divided by 3 times t cubed minus 2 times 2, which is 4, and that will give us 60 feet per second. And that concludes problem 6.